Have you ever wondered what makes software truly reliable, ensuring it does exactly what it is supposed to, without unexpected glitches or frustrating errors? It all begins long before any code is written, with a critical process that shapes the entire testing effort. Determining the test scope for software features means defining precisely what aspects of a software feature will be tested, to what depth, and using what methods. It is the foundational step that ensures testing is both comprehensive and efficient, focusing resources where they will have the most impact on software quality. The why behind meticulously defining test scope is rooted in the practical realities of software development. Without a clear scope, testing can become a boundless and inefficient endeavor. Proper scope definition prevents over-testing non-critical areas while inadvertently neglecting crucial functionalities or high-risk components. It helps manage expectations, allocate resources effectively, and ultimately leads to a more stable and trustworthy software product. First, meticulously gather and understand all functional and non-functional requirements. Functional requirements describe what the system does, while non-functional ones detail how well it performs, its security, and usability. This foundational understanding dictates the primary testing objectives. Next, assess potential risks associated with each feature. Consider factors such as the complexity of the code, the impact of failure on users or business operations, and areas with a history of defects. Higher risk areas warrant more intensive testing. Then, delve into user stories and common usage scenarios. How will real users interact with the feature? What are the typical workflows and edge cases? This perspective helps identify critical paths and potential user pain points that need thorough validation. After that, determine the appropriate test levels for different parts of the feature. This involves deciding whether to focus on unit tests for individual code components, integration tests for interactions between modules, system tests for the entire application, or user acceptance tests for end-user validation. Each level serves a distinct purpose in detecting different types of defects. Subsequently, prioritize test coverage based on the identified risks and requirements. Not every possible permutation can be tested, so focus on high-priority functionalities, critical business processes, and scenarios most likely to fail or cause significant impact. This strategic prioritization ensures maximum value from testing efforts. Finally, document the agreed-upon test scope clearly. This includes outlining what will be tested, what will not be tested, the types of tests to be performed, and the criteria for success. This documentation serves as a critical reference for the entire testing team and stakeholders. An advanced technique often employed here is the use of a traceability matrix. This tool links requirements to test cases, providing a clear visual representation of coverage and ensuring that every specified feature has corresponding tests. Another powerful concept is equivalence partitioning, which allows testers to divide input data into partitions where all values in a partition are expected to behave similarly, thereby reducing the number of test cases needed while maintaining high coverage. Both optimize the testing process, making it more focused and effective. By systematically applying these principles to define test scope, you move beyond mere bug hunting to a strategic approach that proactively builds quality into software. This structured methodology not only uncovers defects efficiently but also fosters confidence in the software's ability to reliably perform its intended functions, ultimately leading to superior software products that delight users and achieve business objectives.
If this helps you fix faster, like, subscribe, and keep debugging with us.